Hey, what's up? Let's do a little bit of math today. So in this video, we're going to focus on graphing in slope-intercept form. Now, hopefully this is something you're somewhat familiar with because I'm not planning on going into too much detail with it. However, this is a super important concept, something that you need to leave an algebra class or just sort of middle school math knowing how to do it. Now, let's do a quick little recap here on slope. Now, if you remember that slope is a ratio, all right, of rise over run. And what that means is where it's the ratio of how far we're going up and down versus how far we're going left to right. Okay? And when we're given some information, it's a fraction. It tells us a lot about what's going on. Now we have four types. We have our positive slope. We have our negative slope. And these are the two that we're mostly going to see when we're graphing equations. Then we have a zero slope. And finally, we have an undefined slope, which is this vertical line here. Now, these two are special cases. We'll address them a little bit, but for the most part, we're dealing with this. I also want to remind you that sometimes if we have slope, which is usually denoted as m, as like a whole number, so let's just say m equals 2, that could be thought of as the same way as saying 2 over 1. Okay, because some students get confused by that. Now we'll take a look at this in a second. So ultimately though, let's talk about what our goals are. I have three goals. One, we are going to start at the y-intercept. Then we're going to use the slope to find two more points, and finally draw a line through the points. Draw a line through the points. Now let's just kind of talk about what this all looks like. Remember, slope-intercept form is y equals mx plus b. M is our slope, b is our intercept. The analogy I like to use is that this is our starting point, and then these are our directions for finding the next point. So let's keep that in mind, and let's go through a few examples. So let's get there in a second. Those are our special cases. All right, so we're going to go three different colors here. So first one, y equals 3/5 x plus 2. 2 is our starting point, and that is on the y-axis. So what I'm going to do is go to my y-axis, and go to 2, and that's where I start. Now I'm going to use my slope 3/5, meaning it's positive, so it's going to go like this. I'm going to go up 3 over 5. Now keep in mind, I have another option. If I want to, I could go down 3 and left 5 if I really, really wanted to. So I'm going to find a couple more points. So I'm going to go up 1, 2, 3, 1, 2, 3, 4, 5. That's 1 point. Then I could go down 1, 2, 3 this way, and I could go over 5 that way. If I want to, I could keep going in that general direction too. So down 1, 2, 3, over 5 more, and then I connect all of these, and I am good to go. So that's it. That's how we graph it. Now let's take a look at this blue line here. We have -5. We got to remember to include that negative sign. So that's my starting point. I start here on the y-axis. Common mistake students make is they start on the wrong axis. They start on the x-axis. We don't want to do that. Now our slope is -2/5. So if it's negative, the line's going to look like this. And so I have two options. I can go up 2 over 5 like this, or I go down 2 over 5 like that. So just for good practice, I'll show you both. So we can go up 2, and then over 5. That's one. Go down 2 over 5 to get the other. Now I have 3 points. I want to connect them and draw arrows because this line goes on infinitely in both directions. You don't want to just stop it at those points. Finally, let's take a look at this one. Y equals -6x plus 1. Well, for this one, something that students get confused by, they're thinking like, well, I can go up 6, right? So my line's just going to look like that. But it doesn't. Our slope is -6 over 1. Now our starting point should still start there. Go to 9 on the y-axis. Is right there. Now, to find the slope, we run into a small problem. We can't go up 6. We're out of places. That's why I really stress this idea. If it's a positive slope, it has to look like that. So we wanted to, we could go up 6 over 1, or we could go down 6 over 1, down 6 over 1, and that's what we're going to do. So we'll go down 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And so this is going to be a pretty steep line. Connect them, draw some arrows, and boom. There we go. All right. So just keep in mind, if you're running out of space on your graph, you could always go the other direction. Just make, oh, whoops, that is wrong. Let's make that up. It's -6, right? So I need to go down 6 over 1 that way. That was a good catch. 1, 2, 3, 4, 5, 6 over 1. Perfect. So again, that's why it's helpful to know about the general direction the line should be going. So this is wrong. Let's fix that. It should be going like that. And yeah, you can always double check. So it's easy to make mistakes, but if we kind of know the general direction, we can fact check ourselves fairly quick on that. So almost done. Last thing I want to talk about are special cases. This is where we just have y equals a number or x equals a number. Now, if we have y equals a number, it's just going to be a horizontal line at that y value. So we go up to 1, 2 on the y-axis and draw a flat horizontal line like that right there. For y equals -1, similar idea. I go down to 1 on the y-axis, and there we go. Now, the reason why this is the case is this equation could be rewritten as y equals 0x plus, or -1, -1. My slope is 0. 0 has a flat line. This is just telling me where I need to start it, and I just keep it horizontal there. Similar sort of idea is what happens when we have x equals. So x equals -2. Instead of it being a horizontal line, it's going to be a vertical line at x equals -2. Similarly, y equals 3, vertical line right there. Okay? So hopefully this is a nice little recap of how to graph in slope-intercept form. If you have any or good luck on your practice, and let me know if you have any questions.